So here's some things you should know about intermolecular forces. Anytime you have two identical molecules, two like molecules near each other, there's going to be some attraction. It might be really low or it might be really high. And that's why there's three different kinds of intermolecular forces, because the really low ones tend to be nonpolar molecules. The really high attraction tends to be something called a hydrogen bond. And the ones that range in between from a little bit to a lot, those happen to have polar bonds. So gases, if you force them close enough together, the intermolecular forces would have an effect. But then they would, like I said, they would hold them in one place and it would become a liquid. When gases are held close enough together for the intermolecular forces to take effect, then we can see it. It forms water droplets. So then it's in its liquid state. So intermolecular forces, a couple things you should know about them is intermolecular forces are referring to forces of attraction between like molecules, and they affect liquids and solids only. Gas particles are too far apart. Just like if you have your magnet too far away from the refrigerator when you leave go of it, it's not going to stick to the fridge. You have to be fairly close for it to stick. Okay? Same thing with these molecules. They have to be close enough that the electromagnetic or electrostatic forces can actually have an effect. So then what are the three kinds? Well, the first one is dispersion. So all the diatomic gases, remember all the nonmetals, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, the Brinkelhoff gases, they're all nonpolar because they're going to share equally. It's just two of the same molecule. And then also if form with nonpolar molecules. So same molecule or a symmetrical molecule. So like C2H6, that's the picture I have there. That's considered a tetrahedral molecule, which I know it doesn't look tetrahedral, but if you look at the carbon on the left, it's got four things equally spaced around it, 3 hydrogens and the other carbon. And if you look at the carbon on the right, it has 4 things equally spaced around it. So that's going to be nonpolar. You should be able to make a pretty good guess if a substance has a dispersion force, because if it's a gas or it evaporates easily at room temperature, that's your hint. It has a dispersion force. There's not much holding it together. Okay, something that evaporates easily at room temperature either has a dispersion force or a really weak dipole-dipole force. It definitely doesn't have a hydrogen bond in there. So then the second kind of intermolecular force, the second strongest one, is this dipole-dipole, and I know it's a dumb name, but remember, dipole is just telling you 2 poles, 2 charges. There's a positive end and there's a negative end. And then there's another one next to it. So the positive end of one molecule attracts the negative end of the next one. So that's why they call it dipole-dipole. So each molecule has to be polar. That's what it's saying. It's the attraction between polar molecules. So these form with polar molecules. Because there's a permanent positive end and negative end. So that's going to make it stronger than just a dispersion force, because there's a permanent positive end and negative end. So what would be your guess that it's probably a dipole-dipole if it's a liquid at room temperature? Okay, but doesn't evaporate quickly like rubbing alcohol would. If it had a fairly strong dipole, it's possible it could be a solid. So the example here, this is H2S, hydrogen sulfide. It's a polar molecule because it's got a bent shape. So I could add that up here. Because the shape is bent, or trigonal pyramidal. Those are going to be your polar molecules. And then a hydrogen bond is the strongest one. This is really just a super strong example of a dipole-dipole. Okay, it's just a dipole-dipole force on steroids. It only occurs with hydrogen bonded to fluorine, oxygen, or nitrogen. And it's super strong because these are 4 of the smallest atoms. Oops. And remember, small is tiny and tight. And you should be able to guess substance has a hydrogen bond if it has to have hydrogen bonded with fluorine, oxygen, or nitrogen. Those are the only ones considered hydrogen bonds. There's other dipole-dipole bonds that are really close to the same strength, but I mean, it's just like the A honor roll, you cut it off somewhere. I know 2.99 was really close. So you get a smiley face and half a donut or something, but it's an arbitrary cutoff.